when it loads. Okay. Hi everyone, welcome to our event. This event is brought to you by Datadogs Club, which is a community of people who love data. We have weekly events, and today is one of such events. If you want to find out more about the events we have, there is a link in the description. So go there, click on the link, check it out. I think right now there is only one event, this one, but there is going to be a workshop which we'll add soon to this link, so keep an eye on that. Then, very important, do not forget to subscribe to our YouTube channel if you have not subscribed yet. This way you'll stay up to date with all our future streams. And then we have an amazing Slack community where you can hang out with other data enthusiasts. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your questions, and we will be covering these questions during the interview. And I think my nose is blocked a little bit. I hope it's okay. It will not interfere with our interview. But anyways,
Everything is great.
Right now, I'm going to open that document with questions that we prepared for you. And if you're ready, we can start. Are you ready?
Awesome. Yep, let's start.
This week, we'll talk about competitive machine learning and teaching, and we have a special guest today, Alexander. Alexander is a machine learning engineer with 10 plus years of experience. He's also a Kaggle Grandmaster, ranked 5th globally, and a teacher to more than 100,000 students. It's amazing. And as a teacher myself, I can really appreciate the number and also the effort. So it will be very interesting for me to talk about that personally. Okay, and Alexander also leads data science and software engineering teams and contributes to open source machine learning tools. So welcome to the interview, Alexander.
Yeah, hi. Thank you for having me. Really great to talk to you today.
And I just want to also say I want to thank Marina. I don't know if she's watching right now, for making sure we get in touch. So for me, actually, I've been following your work for quite some time. And more than 10 years, actually. So long time. Because when you were active on Kaggle, I was also active on Kaggle. So for me, it's actually a good moment to be able to talk to you. So thanks, Marina. And also the questions for today's interview are, as always, prepared by Johanna Bayer. Thanks, Johanna, for your help. So before we go into talking about teaching and competitive machine learning, let's start with your background. Can you tell us about your career journey so far?
Yeah, sure. So my career started, I guess, about 10 years ago when I was like a student at the university here in Moscow. And I was looking for an opportunity to learn machine learning because I thought it's kind of exciting new field. It was pretty new, I guess, 10 years ago. And I found that opportunity on Kaggle. Then I moved to industry. I worked as data analyst at some ad classifier company, then as data scientist and ride sharing services in Yandex. Then at Mechanica AI, which was a startup focused on bringing machine learning to industrial enterprises like factories, plants. Like we flew to like some small cities in Siberia to find like process engineers and plants to figure out whether they need our machine learning or not. And eventually, I worked at Iterative, which is like a company venture startup at San Francisco. They create open source tools for machine learning engineers and data scientists. And after that, I moved like here back in Moscow to work at Central University. It's a new kind of university here, which I mean, is interesting because always education was my hobby. I was teaching like for almost 10 years now. And finally, that hobby became like my career, full-time job.
And since you mentioned Iterative, so I don't know if your colleagues or ex-colleagues from Iterative are watching this now or will be. I just want to thank them, because at some point Iterative was supporting this community, and because of their support, it was possible to grow the community, to bring it to the place where it is right now. So if they're watching it right now, so I want to say thank you. So, and I think when we collaborated, you were actually a part of the team, right?
Yeah. There was a talk. Another like one friend of mine, Mikhail Sveshnikov, was giving a talk at your podcast or like some other event you were hosting on a tool we were building. We were building MLAM, like a tool for deploy ML models.
Yeah,
Uh,
yeah.
yeah.
It was
So
Smlem, right? So
yeah,
it's a
Smalem.
sound that a cat makes, or what? Like I think there is like a weird. Uh, it's an interesting origin for the name, right?
Yeah. So there is an internet meme when a dog sticks his tongue out, it does like this with his tongue, or a cat,
Ah,
and
okay,
that's called
okay.
MLM. Yep. Yeah, we were trying to be funny, I guess.
So yeah, right. Are you still doing anything when it comes to open source?
Not right now. Yeah, mostly I did that when I was working at Iterative.
Okay, okay. And you mentioned you started your career as a student 10 years ago, and it was with Kaggle. So for me personally, Kaggle was a place. I don't know if I actually pronounce it correctly, Kaggle or Kaggle. Anyways, so this is the
It
platform
doesn't
for
matter.
competitive machine learning, which hosts machine learning competitions. So there's like a data set, and you prepare a model, and the model needs to be as good as possible. So for me, it was actually the way in data science too, and I was already working as a data scientist. And then I was lucky to work with also a person who was active on Kaggle, who introduced me, Abhishek. Um, and yeah, for me, this opened like a new world of Kaggle, and I was like, wow, awesome. And for me, the first thing was like, I thought I am good at machine learning. I was good at machine learning. But when I attempted my first Kaggle competition, I found out that I don't know anything. And for me, it was like, I don't know, refreshing. Because like on my model, I studied 2 years. I studied machine learning and things like that, and then I take part in my first competition, and then like I overfit a lot, and my model was like somewhere on the bottom of the leaderboard, and it was like, okay, that's interesting. Yeah. And then I started doing more and more, and then of course your name at some point started to appear because you were doing very well there. Like you were ranking quite high in these competitions. You were getting a lot of gold medals. So I can really appreciate. Like I know it's not easy. It's very difficult to be to get good positions there. So tell us how it actually started and how did you manage to be quite good at that?
Uh, yeah, so like it started. I was studying at university, and I was required to select like scientific advisor and a lab where I can like write my bachelor diploma. And I just selected machine learning lab because it was really kind of fascinating for me among everything I saw. So I decided to try, but I quickly figured out that it's pretty hard, you know. And we had like amazing lecturers, amazing teachers, but the problem was that they taught like theory of machine learning, and it was really hard for me to understand everything. There are like a lot of mathematics, a lot of like everything going on, and I was trying to find out some place where I can test my practical skills, learn something. I didn't know anything at that point, so I found Kaggle, and then we had a great like Kaggle community in Moscow. You should recall like a Kaggle club, like ML trainings at Yandex. Then there was like great Alexander Diakonov who taught us like a
You
class
had
and
weekly. Uh-huh.
yeah.
I think you had weekly sessions where you talked about solutions, like how somebody approached the problem, so they would share the solution with everyone, right? And this way you uh, had some ideas of what to do, right? I think I watched a few of them in the recording back then.
Yeah. So there were like weekly sessions, and it was really important that some people that won this competition that came and explained how they did that and how they approach the problem. Sometimes someone just like wants to tell about new, I don't know, framework on GitHub. So he comes and explain it, and it was really interesting and really insightful. Uh, Yep. And it just I just spent a lot of time on that. So I guess it was my third year or fourth year in university, and I was skipping most of my lectures and classes at university. I was just solving Kaggle competitions. So there is actually one secret. You need to put a lot of time on something.
Uh-huh. Yeah. So skipping lectures, huh?
Yep. Not a
That's
good
the secret.
example.
Okay. Like, but you didn't get kicked out of the university, right?
I was lucky.
You managed to stay.
Yep.
You was so what's the secret? Like, how did you manage to both compete on Kaggle and stay at university without getting kicked out?
I guess it was like it was due to the educational system we have here in my university. We had it. So when you can skip most of your work during semester, and then you need to like really hard prepare to your exams, and then go
Mm.
and just pass them. Yeah, that was
Uh-huh. Okay. Yeah, in Germany it's actually similar. So when I was doing my master's, so what matters is how well you pass the exam. It doesn't matter how well you studied during the semester, right?
Mhm. Yeah. It's mostly doesn't matter.
Yeah.
Like maybe now it's changing.
Mhm.
Actually, the educational system here is changing, so it makes sense when like it matters for you to do something during the semester. Sorry, I need to
Mhm.
close this because
Yeah, yeah. Yeah. So now you're not becoming blind because of the
yep.
sun, right?
Hmm.
Good. Um, so you said the secret was putting a lot of time in these competitions, and actually, I can confirm that. Like, I did well in one competition. It was competition about duplicate detection,
Yep.
and this
By
competition
Avita.
was by Vita. Yes, exactly. And so this competition was for 3 months. So the duration was 3 months, and so I started almost like on the first week and continued taking part in these competitions like for all 3 months. And like every week, I would put a lot of effort in this. And only this way I managed to stay on top. Because like, if I don't put in any effort, then somebody, takes over.
Hmm.
So only by consistently putting, I don't know, 5 plus or even more, 10 plus hours of work per week, I only managed to do this, and this is super difficult. And like, but the amount of things I learned there was insane. Like, I think you can confirm, right?
Yeah. I think this is one of the great benefits of Kaggle. Yeah, like if you put aside like winning gold medals, like to it just makes your understanding of machine learning feel broad. You learn a lot of new frameworks, domains, tasks, and I think it's something really helpful that Kaggle gives to you.
Mhm. For how long did you do this? Because like for me, only one competition. I could do only one competition this way because I was exhausted and I thought like I don't want to see Kaggle again.
Yeah, but you had a job,
But you
right?
you you managed to continue. Yeah, I had a job.
Yeah, I didn't, and I think it was around a year, about a year of
Yeah.
this. So that was a lot. Yeah. Eventually, I managed to find my first job and still participate in Kaggle, but it was much harder. And my first job was like 3 days a
Mhm.
week, so I still had time.
Okay. Was it the data analyst position or something else?
Yeah. At Avita, actually.
Uh, at Avita. Yeah. And these duplicates actually, like it helped me throughout my career. So like I was doing some side consulting because people found me on Kaggle on this competition. Then at work, I was working at OLX, which at some point was the mother company of Avito, where I also had to deal with duplicates. So it was like super. Just one competition was so useful. Um, do you remember your first competition?
I guess my very first competition was something like Titanic or first cover type prediction. Those competitions when you know the ground truth, you can just download it from the internet. It's just kind of for playground. Um, I
So let's say your first serious competition.
Yeah, my one of the first competitions, I mean, maybe it wasn't first, but at all, first serious one. But the first I won at, it was half a year after I started, actually, so it wasn't
Okay.
first. But it was at crowd analytics platform. There was this platform, Indian platform. The quality of competitions wasn't as high as on Kaggle, but there were a lot of them, and there were less cool people participating. It was
Hmm.
easier. And that
Hmm.
competition, I remember the training set was pretty small. So it was a kind of weird competition when you are given just like 300 points in training data and maybe 100 points in test data. So it's really luck, a matter of luck. And I managed to train like 300 models, in live and out fashion. And then make a stacking over it. And
Hmm.
I thought it was really cool, but I don't think it was. No, yeah, but it was fun.
So like 300 points, data points, and 300 models.
Yep, yep.
Amazing. Speaking of, like I remember, so that my solution was also not something you can easily put to production because it was like 2 layers or 3 layers of stacking, which is not really useful, let's say. Uh, but still, you learn a lot from competing, right?
Yeah, yeah, you do. And
Hmm.
eventually you are getting usually you're getting bored to it's getting boring to build this stacking, so you're trying to find simpler solutions that work. Yeah, at some
And
point.
like, did you have any? Yeah, sorry. Please continue.
Yeah, at some point I remember there were some competitions where like top places were taken by people with huge ensembles, like a lot of staking layers, but there always was some smart guy on the like, I don't know, let's say 10th place who like trained a single model and still managed to be the
Hmm.
10th. And that was really awesome to
Hmm.
read these solutions, to understand how people think,
Hmm.
what they do.
Hmm. Did you do anything special to prepare for this? Like you mentioned ML trainings, you mentioned reading solutions. Um, did you do anything else?
In general, I guess you just need to iterate. I mean, I just was iterating when you like solve one dozen of competitions, it's much easier to solve the next dozen. Uh, yep. I don't think you really need to prepare to Kaggle competitions like in advance because as you said, they can take like 3 months. So you have plenty of time during the competition, but it's always like useful to prepare for, let's say, hackathons when you have just 2 days, and
Hmm.
it's worth to set up like infrastructure, I don't know, rent a server, create baselines, learn from organizers what type of problem there will be if you can, and just, I don't know, read some tutorials about that problem.
Hmm. Do you take part in hackathons?
I did, yeah, earlier, but now I'm
Really?
mostly on the
Hmm.
other part, on the part of organizers, these
Hmm.
hackathons.
Hmm. Yeah, we will talk about that too. Like
Mhm.
I'll take a note. Um, but so you took part in Kaggle competitions. You were pretty successful there, and yeah, you also put a lot of effort there. And at some point, you moved to industry. Um, so how exactly Kaggle was helpful? Because we also talked about, all these ensembles that are not realistic. People in real life don't do that. People sometimes like there are other things like people use leaks, people use other things that you're not supposed to use and you cannot use in production. Yet despite all these critiques, there are still a lot of useful things that you get from Kaggle. What were for you these useful things, and how exactly it helped you get your first job?
I guess like there are a few things that Kaggle help you with. The first is like really broadening your perspective on machine learning. Like when you solve dozen or maybe a couple of dozens of competitions, then you know like different domains, different models, different frameworks. And that's really great because when you come to your job and you see some problem, you already know how to try to tackle it. And
Hmm.
that also helps you to choose your first job. So, for example, when you come to interview, they ask you, "Okay, did you solve any practical task?" And for example, we are having such kind of task at the company, and then you can tell, "Yeah, I was solving this kind of task already on Kaggle."
Hmm.
It's not like
Hmm. Hmm.
yeah, as important, but still. And the other thing I think Kaggle is helpful is kind of trying to learn some special things about the data. For example, as leaks, you said leaks aren't useful in production, but you do these kind of mistakes yourself. So when you build your solution, sometimes you just add like the ground truth somehow to your training set, and then you push this to production, and you see it doesn't work, and you're trying to debug it. And when you're on Kaggle, you're solving competitions, you find these leaks, you really kind of trying to understand how people on the other side can do them. So this is helpful. And of course, Kaggle is a great place to kind of talk to other people, learn something from them, maybe build your public profile. This also helps. And eventually, I got to Avito thanks to competitions as well. So I had some uh, like friends in this ML community, like Mikhail Trofimov, who invited me to get an interview to Avito, and well, I was successful, and I started internship there.
Yeah, interesting. And do you think it's still useful today? So compared to 10, 8 years ago when we were starting our data science career, compared to those times, do you think it's still useful to take part in competitions and specifically Kaggle, or there are other better ways of, kickstarting your data science career?
I think it's a great question, and it really, as you said, it just depends on. I mean, as you said, there are different ways. There are always alternatives, right? And it really depends on what alternatives are available for you. So, if you are from, I don't know, for example, from Kazakhstan, I'm initially from Kazakhstan, and there is not a lot of, not many places you can get a great education in machine learning. So Kaggle is still valuable. And also Kaggle has another plus. It's international. So if you participate in Kaggle, if you win, it's great. You can get a job in another country. So it's something that shows your level. But if you are like, I don't know, starting your career in the USA or Europe, maybe Kaggle is not the best option you have. Actually, we had like small talk with I know the one of the people who organized Kaggle Club at Oxford in UK, and he was like he told me that there are no a lot of interest. I mean, there are people who are interested in Kaggle, but I got the feeling that in Russia and in some other countries you have more interest in Kaggle, and I think it's because of opportunities. So if you study in Oxford, you can get, I don't know, to some top AI labs. You can get to internship to in a top company. So why you need Kaggle?
Oh, but also I think in Eastern Europe we just like competitions, like all these Olympiads, competitions, like things like that. Because also, there are these programming competitions. I know there are math competitions, and for some reasons, people in Russia and people in the neighboring countries, in general in Eastern Europe, like those kind of things. Maybe in the UK not so much, or yes.
Yeah, maybe it's because of like strong mathematics in school, I think. Like
Mhm,
uh, it can be correlated.
mhm, mhm. But also, when studying in Germany, I noticed that here there was a lot of focus on group work compared to Russia when it was more individual. Maybe it also plays a role.
Yeah,
What do you think?
maybe I didn't think of that. That's interesting.
And speaking of that, so I see a question from Asfin. Should we do competitive machine learning alone or should we form a team?
I guess it's uh, like it's much better to form a team, but not in the sense that I don't know, you enter Kaggle and you build a team there, but rather having a community where you can talk about this, you can discuss some ideas and stuff, and because it's really helpful. Um, yeah, it's just easier to win, even to win competition and to learn is much easier. So
Mhm.
that's what I
Yeah.
think.
Hmm. Yeah. And also because like at the end, you still might need to do stacking, right? And it's good when there are multiple people in the team, everyone has their own model, right? And then you combine all these models into one.
Yeah, because different people like explore different ways, different models, different solutions, and even you may not go into staking, but you can just average predictions, for example. It may be enough
Mm.
sometimes.
Yeah. Mhm. And I remember this Avito duplicates detection competition. So the team who won, it was Stas, who is also very famous.
Yep, Stas
How to
Semyonov.
say? Like he competed. Stanislav Semyonov, yeah, he competed in a lot of Kaggle competitions back then. So he wasn't particularly good at computer vision, so he teamed up with a person who was. So they kind of they knew that like, okay, I know I'm good at this one, I'm good at this thing, so they united and then they won.
Yep. And they
So
found the leakage in the data. I just I just remember this
yeah,
because
of course.
yeah, now I teach school children to kind of we have now this international Olympiad in AI, and I teach like school children in Russia how to participate, and I was trying to create a lesson about leakages, and I found that competition, and I watched it like the winning
Okay,
solution.
mhm. School children. So how old are them? Are they? I don't know,
Uh,
15 years, 16?
16, 17, and 18, like those who are still in
Okay,
school.
so it's like high school, right?
Yeah. It's
Uh-huh.
like, yep. Yeah, if you want to talk about this, we can do it now or later, because
Uh-huh.
it's really interesting. Yeah, there is, there were like international Olympiad in mathematics, in informatics,
Mhm.
and now they're trying to create such kind of Olympiad in AI. And it's really interesting because I never thought that there are like some school children that can actually like solve these competitions on such high level.
Mhm.
So yeah, because I started my career in data science like in 22 maybe, and I think you also like maybe a bit later, but still.
Mhm.
Um,
Yeah.
so it's really interesting when people at 16 can solve competitions and win
Yeah.
prizes.
Yeah. And I'm also like I'm trying to remember what I knew at school. So when I was at school, I could solve quadratic equations. I'm like some other basic things, but like machine learning, no. Like oh, and we were learning Pascal and Excel and Word in our
The
classes.
same
I guess school children these days are very different. So does it mean they learn machine learning like
by
in
themselves
10th or
mostly.
11th grade? Ah, by themselves. Okay, so it's
Yeah.
not taught at school.
Yeah,
Okay.
it isn't.
Well, not yet, maybe, right?
Yeah, maybe.
Okay. And how did you start your teaching journey? Like you said, I think you were sharing solutions from Kaggle, right?
Yeah. So I was when I ended up at AI lab I was talking about at university, and understood there are like a lot of theoretical machine learning courses. I was trying to find an opportunity to learn some practical things. So I came up across one class that Victor Kantor held in like our university. So I just come to that class, and yeah, it was just like usual class on machine learning, but from practical perspective. I just came there
Hmm.
and asked if I can join, and he told me like, "Are you that guy from Kaggle? So you shouldn't come to these lectures. You should teach." And I decided to try. And yeah, first
So
like
you wanted to join as a student.
yeah, I wanted, I wanted. Yeah, he
Amazing.
said I was overqualified. I still attended because I wasn't
Uh-huh.
overqualified, obviously. I didn't know a lot of stuff back then.
Hmm.
Yeah, but I was like, yeah, teaching how to solve Kaggle competitions even uh, doesn't win
Hmm.
them. Don't win because winning is much harder, but just solving.
Hmm. Hmm. And I think it also benefits because in order to win, you need to exploit all these leaks, build ensembles, which does not directly translate to being good at work, but just having an okay solution, a good solution that works, is already super helpful, right? So you kind of understand the problem, you understand what kind of feature engineering you can do, you understand how you can do cross validation, right? And once you do that, that's sufficient to actually say, okay, now I know how to solve this problem. Let's move on to another one, right?
Yep, exactly.
And so it started with you uh, with that class, and what happened after that? Like you understood you like teaching, or what?
Yeah. I found it like interesting and yeah, fulfilling in some sense. So I really like explaining people some stuff, and I like when they understand this. So I was just
Mhm.
continuing. And also, I learned that I wasn't good back then. I wasn't good at machine learning theory, for example, and I didn't understand a lot of details about ML algorithms, how they work. I knew a lot of stuff from Kaggle, but I wasn't good at theory per se. And I found out that when you teach, you need to figure it out. You need to understand it if you want to come and explain people. So it was really stressful for me, but it was insightful. So I like that as well.
Mhm. Mhm. So the best way to learn something is to teach it, right?
Yeah, I think that's true, totally.
And speaking of theory, so I remember, so when I had machine learning classes as a student, I attended them. So we were covering things like Bayesian machine learning or support vector machines or what else. Like I remember it was a lot of theory and we would solve all these complex equations.
Hmm. Okay, let me try to reconnect. Hmm. Yep. Okay. Yeah, let's wait for Alexei to return. Yeah, meanwhile, I'm trying to find your questions if you have some. But yeah, it takes time.
Hi. So
Awesome.
the stream is
Yeah, you're
still
back.
happening. Good. So I had to switch to my mobile internet. Something happened with my home internet. Okay.
Mhm.
I do not remember the question I asked. So maybe you have some memory of it.
Yeah, you were asking about teaching, like
Theory and practice, right?
yeah, yeah, yeah. So
Yeah. So
you were actually talking about an example of yours.
mhm. Yeah. So I was. I remember studying. So first I studied theoretical machine learning, and then I attempted to do practical machine learning on Kaggle too. And we were learning like Bayesian methods. We were learning support vector machines, and none of these things were useful in practice. Like when you actually do Kaggle or when you work as a data scientist, we didn't study gradient boosting. Um, like we didn't study many things. And for you, so for me, it was first theory and then practice, and for you, it was first practice and then theory. So I'm wondering how it affected the way you approach theory and the way you teach these theoretical skills.
Yeah, it really has an impact because I still don't like a lot of theory, to be honest. So I really believe in that to learn something, you need to see how you can apply it. So what is the eventual application? And because of that, when I teach, first of all, I don't teach like classical machine learning classes, for example, and I don't know how to actually be good at that. So I teach mostly something about industry, like production machine learning, which is like similar to MLOps, like how to use I don't know DVC, MLflow, Fast API, Docker, Kubernetes, how to deploy your models, how to monitor them, that kind of stuff. And when you teach this, you can just teach on examples. You can show the tool, you can show the problem that you need to solve with that tool, and then you can show how you solve it, and then give a homework. So that's really something that from the different angle, you show some, there is a
Hmm.
problem, let's figure out how to solve it.
Hmm. Yeah, that's like for me, it's also the best way to learn. Because I remember, like, I think the example we used when doing machine learning was like something related to fish. I don't know, for me, it was not relatable at all. And I think if we just used even this Titanic data set, like, would be way better. Like, I don't really like the Titanic data set because it's kind of weird, right? Because you predict who would survive and who would not. Like, to me,
Yeah.
like, it's a weird, like, it's a super strange problem. But like, I don't know, like, take any other classical data set like Boston housing, right? Then, yeah, it's very relatable. And one of the things you mentioned, so you teach practical things and industry machine learning, not classical machine learning. And then you said Docker, MLflow, DVC, Kubernetes. So this is definitely something, or not maybe not definitely, but I suspect this is not something you picked up on Kaggle, right?
Yeah.
So you probably learned these skills elsewhere. So how did you actually develop the skills and yeah, like for a person starting a career of Kaggle, like how do you actually go into this direction of productionizing machine learning and learning more about MLOps?
Yeah, it's actually, I think it's very interesting example. I mean, if like how I moved away from Kaggle. So I moved to, I started my career, like industrial career in Avito as a data analyst. So there, I still was participating in Kaggle, but I saw that you cannot like make up for living by being in Kaggle competition. So I decided to start a job in industry. And at Avito, I understood pretty quickly that my Python skills are lacking and my machine learning theory understanding is lacking. It's how it's vice versa compared to your example when you were working at some like job as data scientist, then you come to Kaggle and then you see you can't compete. This was like vice versa, exactly. And I understood that there is like a lot on machine learning outside of Kaggle. So that was very interesting for me. So I decided to continue. I started the position in Yandex Go as a data scientist. There, I learned a lot of about like let's say statistics, A/B testing. Also, I learned something about Python as well. But there I understood that, when you work in a big company like Yandex or Google or like Meta, you always are like small part of this big machine. So there are a lot of people who do this machine learning, and the pipeline is pretty big. There are maybe a dozen of people who are involved in rolling out some new model, or maybe more than a dozen. And your skills are pretty narrow, and I wanted to learn outside of this. So I moved to Mechanica, where uh, I had to learn Python, like Docker, Python packaging, Kubernetes, Fast API, and it was painful, but it was really interesting because yeah, I understood there that I'm kind of becoming a full stack in the sense I can talk to business, I can understand their problem, then I can build a like solution, then I can put it in production, I can conduct A/B testing, I can measure results, I can report these results, set up monitoring. And that was really fascinating because you are not staying in one like simple, I don't know, small task, but you are owning all of the pipeline. And that was really cool. And then well, that's how my career developed. So some people,
Mhm.
take one. I mean, I have good friends like Mikhail Sveshnikov, who we were talking about him, right? And he is like Python developer and machine learning. He's a god of Python. He can do like so complex, so complicated things. And he's like Python developer in machine learning for 5 or 6 years, maybe even more. And he's like really great at this. And I isn't that type of person. I'm trying to pick up like different challenges for myself during my career.
Mm. Yeah, that's interesting. Well, eventually, both you and Mikhail, ended up doing similar things. You just started from different
Yeah,
positions, I guess.
yeah, exactly.
That's interesting. And speaking of teaching, so teaching is a topic that is very um, close to me personally because doing, I've been teaching for, I don't know, the last 4 or 5 years. So I'm really curious. So we talked about like how you started your teaching journey, which is a really interesting story. But how do you approach teaching now? So you're working for a university with a practical and with a focus on practice and industry orientation. How do you approach coming up with a curriculum, with what to include in the courses, what to teach?
That's a really great question. And I think there are like different ways of doing this. But what I found for myself is that I'm trying um, to come up with some problem that's interesting for students to solve during the class. And then build curriculum around it. So, for example, for like MLOps class or production machine learning, uh, I want students eventually what I want them to do. I want them to learn all of these tools, like again, MLflow, Docker, FastAPI, Grafana, Prometheus, whatever. And it's really can be boring if you just give the tool and give the task. So I'm designing a competition. I mean, it's again a competitive background, I guess. I'm designing a problem for the whole semester. So they need to build a classifier that can, like given a dialogue between two people, the classifier can tell who is the like bot, AI model, whatever, LLM, and who is the real person. And we are building a platform where these classifiers can like get data from, and then we'll have like them competing with each other. And throughout the class, like students just build the same, like build upon what they did previously. So they start with some dummy classifier that just gives a random number, random probability. Then they add they collect data, they use Label Studio to label that data. Then they train model, the log, they experiments in MLflow. Then they wrap it in Fast API, they deploy a machine learning model, and they see metrics on the leaderboard, technical metrics, not actually machine learning metrics, but like technical, how well their classifier, is it online, like the uptime, the speed of response, stuff like that. And I think like this is a really good approach. Just find out something interesting for students and build curriculum around it. So yeah, if you allow me
Mhm.
another example, we have another class currently
Yeah,
like machine
please.
learning. Okay, thank you. So we have another class like machine learning system design, and it's kind of a broad topic, like what you can teach in machine learning system design, practically how to approach any problem in like business problem with machine learning, how to like do everything, build prototype, conduct A/B testing, whatever. And we are suggesting students to find some idea they can work at, they want to work at during the semester. Maybe they want to build a AI startup. Maybe they want to solve smaller problem. And I think when people select something they like, they are more like they tend to this to actually like this problem and like spending time on it.
Yeah, that's really interesting. In the second example, sorry, my internet is not really good. That's why
I
there
can
is a
hear
bit of lag
you.
between.
Yeah, but
Good, good.
mhm.
There is a bit of lag. So for the second problem, when you encourage students to select the problem to solve themselves, do they form teams or they work individually? How do
Yeah,
you
they
approach
form
that?
teams. Yep, because
Hmm.
well, yeah, we also want to teach them, let's say, working with Git, for example. We still want them to
Hmm.
build prototype, and we
Hmm.
also want to learn them how to communicate between themselves because it's really part of your job.
Hmm. That's amazing. And in the first problem, you said you want to make it competitive, so you design a competition. I understood the problem that okay, they need to eventually build a platform for classifying who is bot, who is a real person, and then you iteratively progress from a dummy classifier to like a full platform with metrics and whatnot.
Uh,
But where
it,
is the competitive aspect?
Yeah, I think I wasn't clear enough. So what they built a classifier, which like is just, let's say, fast API service, which can receive requests, and then they plug it into the platform we are building outside of the class. So we have some
Ah,
like extra project in university. We are building this platform, and student just deploys a classifier. And on the platform, when you like different students attach different classifiers, they will be able to see some metrics, right? So it's really
okay.
something similar. I guess it's a bit
Hmm.
similar to production. So you can like as ML, like engineer, whatever, whoever, you just build something, you can add, I don't know, monitoring to it. You can add retraining, you can add CI/CD, like whatever. And then there is some system that consume your predictions, that gives you data, consume your predictions, and you need to make your like your classifier work with it pretty well.
Yeah, that's interesting. And then do you have some sort of leaderboard?
Yeah. It's there are like two types of leaderboard in this. There is an ML metrics leaderboard, like which classifier is like smarter at detecting bots, and there is a second leaderboard, like technical leaderboard with uptimes, times of responses, error codes, and stuff like that. And on this class, I want to focus on the technical leaderboard because I don't want like actually Kaggle competition there. I want for
Hmm.
students to try
Hmm.
to build the most reliable solution.
Hmm. This is an amazing idea. Maybe we should also try to do something like that in our classes. But I'm wondering, so for you, so these are master students, right? So your
Yeah.
classes are not large.
Yeah. They are not large. Like currently, the university isn't big. We have like around 200 students in master's degree, but they are like in different directions. Like in machine learning, we have around 100, maybe a little more, 150 students. And so on the class,
Mhm.
there will be like 80 students or something. So a lot, but not that a
80, but
lot.
this is still a lot.
Yeah.
Uh-huh. So it's a significant number compared to like, I don't know, usual classes, at least the one I had. But it's not like the same because you also have experience in teaching in online courses, right?
Yeah, right. On
Because this is
Coursera
where the
and
number of 100. Okay.
mhm. Yeah.
Because like you in your bio, it says 100,000, which is obviously not university. It's Coursera. Was it Coursera?
Yeah. It's Coursera actually. So I think it's and Coursera is totally different format. You just build a class, you just publish it, you design like some automatic procedures to check solutions, and then you have some people on the platform who answer questions, and maybe you sometimes answer questions. But
Hmm.
when there are like so many
Hmm.
students, it's hard to do something. I mean, uh, otherwise.
Hmm. Hmm. And was it a class on how to win Kaggle, how to win ML competition,
Yeah.
something like that? Yeah. I think I remember this class, this course. I didn't take it. I remember that you were doing it. Yeah, that's amazing.
Mhm.
Great work.
Thank you.
Okay, and I really like the idea of building a platform and then letting students take like plug in their ML models. And since we're doing online courses, maybe it's not as simple to implement this because you have more like closed environment with students, so you kind of know the number of students. But maybe this is something we can borrow too in some of our classes. That's really interesting.
Yeah,
Okay.
maybe you
So,
want to use this platform. We can discuss it as well because
is it open source?
it isn't open source, but I think we'll host it like so anyone can use it in this way. But it's because I want to like we actually want to reuse it in some other classes outside of the university, both in Moscow and in Europe. So maybe it will be like
Mhm.
uh, good option to try it. Maybe.
Yeah, let's talk. Do you actually take part in developing this platform as a
Uh,
developer?
it, no, rather than
No.
the one, yeah, who asks to develop it, actually. Yeah, but
Okay.
yeah, I'm still closely
Are
connected
Yeah.
yeah to
Mhm.
this.
Mhm. Are students developing it, or it's like
Yeah,
professional
yeah,
software
yeah.
engineers?
The students, it's just like in the university, we have an idea that students, before they find a job, they can test their skills and get like close to job experience at some projects at the university. And some projects are from external
Mhm.
like companies, and some projects are from internal people. And this is this kind of project. We actually have three students developing it, and they're really great. I mean, they are like junior or middle level. So I was happy to I was
Mhm.
lucky to find them at
Mhm.
uni.
Mhm. I'm just curious how it's organized because students, they are not experienced, so they need mentors. And also students maybe do it for half a year, but then I don't know, they graduate or they finish the class or whatever. So then there is another student who spends again, like, I don't know, another half a year. So this work needs to be organized in such a way that new people can come, old people leave, but the process is still ongoing, and then there is somebody who can mentor all the students, right?
Yep, that's true.
You get somebody from the industry
Yeah,
to
yeah.
mentor, or
We for each project we have a mentor, and in this case we have a mentor from T-Bank, which is kind of Tinkoff company. And he's also like spending a lot of time with students. He's reviewing their pull requests. He's helping them to fight some challenges there. And regarding if some of the students want to move out from this project and we want to find another one, we're trying to kind of, again, as with any software project, we try to document things, like make code like look easy enough to understand and stuff. But we're only doing this project for like 3 months, I think, and we are launching it 1 week later. I mean, in the end of January, we actually have like 5 days hackathon for master students at university, where they'll try to build the best machine learning solution. If on the MLOps class, we want them to build the best technical solution, here it will be the best model, and we'll test the platform. And I think it will, well, maybe we'll have maybe some of the students will go out of the project in a few months, but then we'll solve this somehow.
yeah, that's pretty interesting. Thanks. There are a few questions. Do you have maybe? I see that we should be wrapping up soon. Do you have like maybe 5 more minutes?
Yes, of course.
Okay, okay. Because um, there are a few questions that perhaps we should address. So one of them is pretty interesting. What is the best way to convince your managers about the value of Kaggle and ML competitions?
Yeah, that's a tricky question. Um, I think I think things like that, they are easiest to go with by using some example. Maybe you can find someone like in your company who solved Kaggle and who is pretty good, and show this as an example. Maybe you have someone at industry who is well known for your company or your managers, maybe some advisor who solved Kaggle competitions. Maybe you can use that as an example. Otherwise, I mean, also it's important to understand what the value you're trying to get out of this, right? If the value is just to, for example, to introduce Kaggle as a side activity to your company, I've seen these examples, and it's usually, uh, well, you can just show that other data scientists are interested in solving Kaggle competitions on some basis, like, I don't know, a Kaggle club at the company. And sometimes there is a green light for these initiatives. So, yeah.
Mhm. So basically, show them a good example, right?
Yeah, I think
Mhm.
that's it. I don't have a better answer, to be honest.
Mhm. Yeah, that's a good answer. Another question: is there any secret trick that works almost always in competitions?
Yeah, that's also a great question because the competitions are unique. I mean, in the sense that we are talking about winning competition, right? And if you take a look at the top solutions on the leaderboard, they are usually unique in some sense, and they really heavily depend on the data, on the problem, on the information organizers gave you. So it's really hard to come up with a single trick, um, really. But what I can say is that there are some things that almost all of competition winners do. They explore the data, they do that carefully, they try to do EDA, they try to understand the domain, and build a careful validation, let's say. All the usual things, but when you put this together and do very carefully, it works.
Yeah, right. So the secret trick is just be careful and invest time, right?
Yeah, and invest time. That's really important.
Yeah. Uh-huh. Okay. And what is your opinion about generative AI? Like, how does it affect competitive machine learning? Like, do you see that people use it more often, less often?
That's a really good question. I mean, if we are talking about I don't know, ChatGPT or like Copilot, Cursor, I think people use it, but it's not. It gives you some edge maybe to your productivity, but it really it really can't win competitions. I mean, in after ML sense, let's say.
Hmm.
Uh, but I see it's really useful. I mean, for example, myself, when I solve some problem with, I don't know, with cat boost, for example, I just copy paste the error log and put it to ChatGPT, and it helps me sometime to fix the problem. So
Hmm.
in this sense, it's useful.
Hmm. Okay. I remember, so back in the day when I was taking part, there were people who were doing these AutoML solutions.
Hmm.
I think one of them was Casanova. Maybe you remember that guy.
Yeah, yeah, yeah.
So he wrote some weird Java code that would just take a problem and then train like a lot of classifiers and then do ensemble on top of that, and that gave a good baseline. And then eventually he would just improve this, and he this way he won like a lot of competitions, or at least he got a gold medal in many competitions. Do you think this approach still works these days?
Yeah, it still works. Actually, just recently I was talking to Alexander Guschin, who is like I think now he's grandmaster in every category on Kaggle, like in competitions, discussions, kernels. So what is the last category? And he
Data sets.
develops, yeah, data sets. Thank you. And he develops AutoML solution like Llama AutoML. And he told me that it really gives you good baseline. You just put it, you get a baseline, then you improve, and then you can win. So it works, but it cannot deliver you winning solution alone.
Okay. So it's just like before, maybe it was some obscure Java code that somebody developed and didn't want to share with anyone. But now these days, it's because we have access to this AI solutions, LLMs. These tools become more mature and also more complex, right?
Yeah, and open
Like better.
source, some of them,
And
at
open
least.
source, yes,
Yeah,
yes.
FlightOML is open source, so
Hmm.
um, that's pretty cool actually.
What's your current Kaggle rank?
I don't know. It's bad.
I just checked mine. It's 9,575.
Oh,
So
I
yours probably
guess,
better. Because
but not a lot, I think.
they have only one gold medal. Yeah, and you have like, I don't know, 10 or how many
Around that. Don't remember
around
now.
that. Okay.
Yeah, yeah, but it doesn't matter anything now. I mean, it doesn't mean anything now. Yeah,
And people still recognize you, you know?
yeah, yeah. I mean, it was really useful in this sense. So, and I was really lucky to start competing on Kaggle, and I think it's you see even today's interview, it's happening like the title is I don't know competitive data science. Although
Mhm.
I'm machine learning
Right.
engineer now for 5 years or so,
Mhm.
uh, we're
Yeah,
still
right.
talking about this.
And you don't actively compete now, do you?
Nope, nope, nope.
Mhm.
I'm teaching some of the things I still find valuable to students,
Mhm.
but I don't compete. Actually, I have,
Mhm.
maybe you know this guy. There was, maybe no, not. There was one person from our like community at the time, Sergei Arefiev, he was actually from Saint Petersburg. But what's amazing about him, he's still competing and like 8 years passed and he's still competing and this is his only occupation and he makes enough money to to live and
So
I find this
he
amazing.
wins money, enough money to actually live off the prizes.
Yeah, 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 he does. And
Not
I
bad.
found, yeah, and I was like, I teach Kaggle, like, I mean, something about Kaggle for my students at university, and I was trying to find a person who actively participates. and who
Mm-hmm.
can teach not just outdated things, but something really
Mm-hmm.
like current. And I found him, and he's really
Mm-hmm.
great. He's winning competitions in Kaggle, and like here in Russia, the competitive level is lower than in Kaggle, so he makes up for the living.
Mm-hmm. Yeah, I checked the current leaderboard and I recognize only one person out of, I don't know, top 25 that I checked. So everyone is different now.
Yeah, yeah.
Okay, Alexander, it was really great to have you here to talk with you, to ask you questions and get your perspective on things. So thanks a lot for finding time and joining us today. And also thanks everyone for joining us today, asking questions, being active. So yeah, it was amazing. Thank you.
Yeah, thank you, Alexei. Thank you, everyone. Bye.
And sorry for the connection problems. Yeah, have a great week.